guys, and welcome to Sum Things Up. Today we'll be talking about how to find the limit algebraically of functions with radicals in them and complex functions. Today I'll just be talking about just this topic, and I'll try to push out other topics too, but just their own video. That way you guys can go through and just review the topics you need to. So let's get into it. Okay, so I just want to preface this by saying that this is only for the 0 over 0 rule, because if it's not 0 over 0, why are we solving? Just plug in. So for this first problem here, we can clearly see it's going to be 0 over 0. So when it's a 0 over 0, we have to cancel something. We have to factor, right? How do you do that? If there's a rational, you take the opposite. You take the conjugate. So, and you multiply that by the top and the bottom. Because what you do to the top, you do to the bottom. Okay, so we'll multiply this by, x plus 4. This was way too long. What? Okay, plus 3, not minus 3 because we're taking the opposite, over x plus 4 plus 3. Okay, now we can solve. So we have limit. Always rewrite the limit if you're not plugging it in. If you're still solving, rewrite the limit. Okay, what's square root of x plus 4 times square root of x plus 4? It's x plus 4. Okay, negative 3 times positive 3, negative 9, right? Simple. Over, we have x minus 5 times square root of x plus 4 plus 3. Whoops, let's make that longer. Don't, distribute in the numerator, in the denominator, okay? Because it's going to make it more complicated. And only distribute like when you have to, but usually try to do it in the numerator. That way you can just cancel things out easier. Okay, so this would be x. Oh, guys, see, I just made a mistake there. What did I do? I didn't rewrite the limit. Limit as x approaches 5. Okay, this is x. What is that? Minus 5. Oh, what can we guess was going to cancel? Yeah, we could have guessed that. Okay, let's rewrite this. Limit x goes to 5. Also, I just want to preface this, guys. Well, let's take out a paper. Let's do this problems with me, okay? Because why am I doing this alone? This is how you get the review in, is you practice. Oh my gosh. Did you guys catch that other mistake too? Wow. Okay, now we can finally plug in. So we have 1 over square root of 5 plus 4 plus 3 equal 1 over, what's the square root of 9, guys? 3. 3 plus 3, 6. Okay, boom. We know that that's the answer. You see what I did here? I stopped writing the limit here because we plugged in. Okay, so this is the answer. Moving on. Okay, so question number 2, I encourage you guys to pause the video, try this problem on your own. I'll do it now, and I'll cut to the answer so you guys can check, because I think you guys should be doing this, like, try practicing on your own. That's how you build up the skills. This is the answer in the work that I got to show the answer. It's -6, so hopefully you guys got that too. But the tricky thing about this was knowing that x minus 10 and negative x plus 10 cancels out to -1. Just, if there's inverse signs, but the same numbers, just know that it usually cancels to -1. So there we go. That's all we need to know for radicals. It's usually just that thing. Just always remember conjugate's the opposite. And remember, if it's the opposite, switch the signs. So now we have complex fractions. So same thing, only plug in if it's 0 over 0, guys. This should be engraved in your head by now. But let's see. So we're going to have to make the denominators equal on the top and on the bottom so we can cancel them out. So we're going to have to multiply everything by a common denominator. So for this, the easiest thing would just be to times them by each other. So make this times 4 times 4. So it would be, the denominator is going to be x minus 4 times 4. So we're going to multiply this by x minus 4, multiply this by 4, and the top here is going to be 4 times x minus 4 over 4 times, oh my goodness, hello, x minus 4. So now all the denominators on the bottom are equal. We can cancel them out. And on the top are equal. Oh, wait, sorry. We're not canceling out the x, so that's on the top. Because this is x over 1. Always think about that. So if you're doing x over 1 times 4x minus 4 over 4x minus 4. The x is going to end up on the top, so it's not on the bottom. It's bothering me. Okay, now we can plug in. So we have the limit as x approaches 0. With the bottoms canceling out, we have x times 4 times x minus 4 over 4 plus x minus 4. Okay, it's so much easier if you just think about it, keeping everything in like fractional form, not distributing. Okay, so now let's go equals limit of as x approaches 0 of x times 4 times x minus 4 of x, because 4 minus 4 is 0. Cancel these x's out. We have limit of as x approaches 0 of 4 times x minus 4 over 1. Okay, now we can plug in. Yippee-ki-yay! So which is equal to 4 times 0 minus 4 equals 4 times negative 4, which is equal to negative 16. And notice I did not write the limit after plugging it in. Okay, so for question 4, I would tell you guys to do this on your own, but I feel like it's a little bit tricky, so I think it might be easier for me to walk through it. So we need a common denominator. So don't worry about, even though it's squared, like don't worry about factoring that out. Worry about that later. Keep everything in the simplest form. Do x plus 3 squared. Make the common denominator 9 times x plus 3 squared. So x plus 3 squared times 9 times 9. Then this is going to be 9 times x plus 3 squared over 9 times x plus 3 squared. Whoops. You guys get the point. Bottoms cancel out. Perfect. Okay. I know this looks like such a mess, but just trust the process. Okay. Limit as x approaches 0 of 9, right, minus x plus 3 squared. Whoops. Okay. Over, bottom cancels, x times 9 times x plus 3 squared. Okay. Now, we do not want to touch the denominator, just focus on doing stuff with simpling out the numerator. So we'll have limit as x approaches 0 of 9. Let's factor out the x plus 3. So 9 minus x squared plus 6x plus 9 over x times 9 times x plus 3 squared. Okay. It's just gonna be like so much busy work, but honestly I love doing this busy work. I mean, kind of just really like it. Okay. Here we go. 9. Oh wait, sorry. It's easier if I just don't put it in parentheses. 9 minus x squared minus 6x minus 9. Let's just like rewrite this instead of writing limit again and again. So we have negative, oops, negative x squared, 9 minus that. Okay, it's just gonna be minus because we add 9. Okay, over x plus times 9 times x plus 3 squared. Okay, now we have to factor out. What can we do with the numerator? Factor out an x. Or let's factor out a negative x. X minus 6. No, x plus 6, because we factored it out. Negative. Okay, x times 9 times x plus 3 squared. Oh my gosh. Okay. Those cancel finally, but we're left with a negative on the top. Don't forget that negative. Limit as x approaches 0. Oh my gosh, my hand is getting tired. Minus x plus 6 over 9 times x plus 3 squared. Okay, finally, we can plug in. That gets rid of the limit notation. We don't have to write that again, thank goodness. Okay, plug in 0. Okay, negative 6. 0 plus 6 is 6. 0 plus 3 is 3. Squared is 9. We have 9 times 9, which is equal to negative 6 over 81. Yeah. Finally, okay, that's all you guys need to know. Okay, guys, so to sum things up, we just learned how to rationalize functions with radicals and find their limits, and how to find the limit of functions with complex fractions. Here are some extra practice problems if you guys want to screenshot this and just work on your own, because we went over the basics. You can still practice that, and hopefully you guys learned something. Hopefully this cleared things up. Thank you guys so much for watching.